This time on Spinners with Balls, let's see just how large you can make a spinner that fits in your hand. Let's look at the design first. So the goal of this design was to see just how large I could go with the spinner that would fit in my hand with a bearing that I had found on Amazon. The bearing is 52 millimeters OD and about 25 millimeter ID. So quite a bit larger than the typical bearing. Since the inner diameter is so large, I wanted to go with something different for the finger rests. So I came up with a quick sketch that's 25 millimeters in diameter and 18.8 millimeters in diameter on the inside. This allows a 19 millimeter bearing to fit inside, and that will be the finger rest for the entire spinner. So after that was done, I went ahead and extruded that sketch up, and then chamfered the top and bottom so that it would fit within the bearing. The 19 millimeter balls that I'm using, these are about 3/4 of an inch, are a tad bit larger than the 15 millimeter height of the bearing. So that's why I added the chamfer. With this in place, I printed this, tested this to make sure this would fit on the ID of the bearing. And that did, so I went to the next step, which is creating the actual spinner. This sketch was simple. I did 51.5 millimeters to account for the 52 millimeter outer diameter of the bearing so that it's a snug fit. Then I went with 18.8 millimeter circles around the perimeter for the 19 millimeter bearings, and then I added additional holes throughout of 12.6 millimeters to account for a 1/2 inch bearing if I decided to add that at a later date. So once those were all sketched out, simply close the sketch and extrude that up, and you have the basic spinner. Now a solid block doesn't look good, of course, for a spinner, so after quite a bit of design changes back and forth, I went with simple chamfers on the edge. Those are about 2 millimeter chamfers, and that matches with this inner lug for the fingers. Since again the bearing itself is about 15 millimeters in diameter. I'm sorry, 15 millimeters in height. So after this was done, I went ahead and did another chamfer for the large holes, and then an additional chamfer for the smaller holes. So this is the finished design. The overall design to replicate would take maybe 5 minutes. Within the sketch, all you do is create one of the holes and then just do a circular pattern to create as many as you want. So it's a simple design, it's quick. Let's see what the final design looks like. So here's the finished piece. It really is massive. Let's take a look. It's almost 340 grams, and that is almost 12 ounces. There's still holes for another 5 bearings that could be placed. I believe these are 1/2 inch bearings. So you might be able to get it up to a full pound spinner if you were to go with tungsten for those bearings. How well does it spin? Well, about as well as you would expect for an ABEC 3 bearing. Now to be fair, I haven't cleaned this bearing as well as I clean most bearings. So another cleaning, and I should be able to get a spin time up to about 45 to 60 seconds from the current max spin that I've been able to do with this design of about 20 to 30 seconds. But the overall design gives you an idea of what is possible even with very large bearings, or at least very large bearings for spinners. It might get you thinking on what you could design. So have a look at McMaster-Carr or on Amazon, search for bearings, see what you can find that you would like to design off of. Until next time, keep designing.